Section 4.4 Graphs of the secant and cosecant functions. These sessions, we're going to learn how to graph the secant and cosecant functions. And you can obtain the graph of the two remaining trigonometric functions from the graph of the sine and cosine function using the reciprocal identities. Remember that secant x that will be equal to 1 over cosine x, and cosecant x that will be equal to 1 over sine x. You guys know how to graph the cosine and sine, right? We could use this identity to graph the secant and the cosecant. For instance, at a given value of x, the y-coordinate of secant x is the reciprocal of the y-coordinate of cosine x. Of course, when cosine x equal to 0, the reciprocal does not exist. Right? When cosine x equal to 0, when you plug it in, then that will be 1 over 0. So when x equal to 0, secant x, that will be undefined. Near such values of x, the behavior of the secant function is similar to that of the tangent function. In other words, the graph of the secant x equal to 1 over cosine x have vertical asymptote when cosine x equal to 0. Okay, let me explain like this part. From the section 4.1, you guys learned how to graph y equal to cosine x or y equal to sine x. Let's look at this example. Y equal to cosine x, that is from negative 2 pi to 2 pi. If I would like to graph y equal to secant x, I will take advantage of this identity. Okay, so we could plug it in. When x equal to 0, cosine, that will be equal to 1. When x equal to pi over 2, cosine is going to be equal to 0. Pi, that will be negative 1, 0, and 1. Okay, now we're going to use this table to graph the secant x. When cosine x equal to 1, then that will be 1 here. When x equal to pi over 2, cosine pi over 2 will be equal to 0. So in this point, that will be undefined. When x equal to pi, cosine pi, that will be negative 1. So I still get the negative 1 here. One more time, 1 over 0, that will be undefined. And this is going to be equal to 1. Okay, right? So from here, they say the graph of the secant x have vertical asymptote when cosine x is equal to 0. So we could see when cosine x equal to 0, I will have the asymptote here. Same idea, this part. Also, when x equal to negative pi over 2, cosine will be equal to 0. Then this is also the vertical asymptote. One more here. Okay, now you could see when x equal to 0, secant x will be equal to 1. And when x equal to pi, secant x will be negative 1. Same idea here, here, and here. Okay, right? So remember the vertical asymptote. The secant x is only be approaching to this line, but it's never touching it. So my secant x, the graph is going to be looks like that. It's going to be approaching it and just looks like the U touching this point and then approaching here. Okay, same idea here. And same idea for this one. Okay, approaching to the vertical asymptote. So the green one, that will be y equal to secant x. Another way to think, if you guys know how to graph the y equal to cosine x, whenever the cosine x equal to 0, that will be the vertical asymptote for the secant. Okay, and then that will be looks like the U shape here. Okay, f of x equal to secant x is going to be looks like that one. Okay, the gray one here, this is going to be y equal to cosine x. Okay, look at the domain. The domain will be the possible values of the x. So you know that x cannot be equal to pi over 2 plus n pi. When n equal to 0, x cannot be equal to pi over 2. When n equal to 1, x cannot be equal to 3 pi over 2. Okay, same idea with the negative one. So this is going to be the domain, all of the x except this. And then the range, that will be all the possible values for the y, right? You can see that the range is going to be cutting from here. Okay, range, that will be all the possible values for the y. So you can see the secant x is only like above the 1 or below the negative 1. So we're gonna say starting from negative infinity until negative 1, or starting from 1 to the positive infinity. So that will be the range. Okay, period. Period is talking about this part here. That's one period, right? So it's gonna be the same thing, 2 pi. Vertical asymptote. So talking about this line here. So that will be similar to the domain, right? X equal to pi over 2 plus n pi. So talking about the red line here. This is a vertical asymptote. And then symmetry. That will be the y-axis. Okay, y-axis. And then the function is an even function. For all x in the domain, secant of negative x will be equal to secant x. Okay, even function. I need you guys remember how to graph the y equal to secant x. One more time, if you guys know how to graph the cosine x, you should be able to graph the secant x. That's the same idea for y equal to cosecant x. Okay, cosecant x will be equal to 1 over sine x. So if you know how to graph y equal to sine x, same idea. Whenever sine x is equal to 0, that will be the vertical asymptote of the cosecant x. Okay, so same thing, domain, all the x, and x cannot be equal to n pi. So n equal to 0, to be talking about this point. So this is also the vertical asymptote. When n equal to 1, which is going to be pi, x cannot be equal to pi. 2 pi, 3 pi, or negative pi, negative 2 pi. The range, that's the same idea with the secant, right? That's from negative infinity until negative 1, or starting from 1 until positive infinity. Period. So this is called one period. Okay, going down, going up, and then that's another here. So that will be 2 pi. Vertical asymptote, that will be x equal to n pi. Symmetry, that will be the origin. Okay, so the function is an odd function. For all x in a domain, cosecant of negative x will be equal to negative cosecant x. Okay, guidelines for sketching graph of cosecant and secant function. So step 1, graph the corresponding reciprocal function as a guide using a dash value. So if you want to graph y equal to a cosecant bx, first, you're gonna use y equal to a sine bx as a guide. If you want to graph the secant, then you'll be using the cosine. This is the step 1. Step 2, sketch the vertical asymptote. Find out when will be the sine bx equal to 0. That will be the vertical asymptote of the cosecant. Same idea, when you have a cosine bx equal to 0, then that will be the vertical asymptote for the secant here. Step 3, sketch the graph of the deserved function by drawing the typical U-shaped band between the adjacent asymptote. Okay, between each of the vertical asymptote, you're gonna draw the U shape. Okay, sometimes it's upward, sometimes it's gonna be the downward. Example 1, graph y equal to 2 secant 1/2 x with 2 period. Okay, so before that, we want to graph the cosine one. okay, because secant x equal to 1 over cosine. So first, we're going to graph the corresponding reciprocal function, y equal to 2 cosine 1/2 x. Do you guys remember how to do it? First, figure out the amplitude, refraction, period, and the y-intercept for the cosine. So amplitude, that's going to be equal to 2. Do we have the refraction? No, right? Because this is a positive, no refraction. Period, that will be 2 pi over b. And your b, that's equal to 1/2. So 2 pi divided by 1/2, which is 4 pi. Okay, y-intercept. Since we do have an amplitude is 2 here, and then we don't have the refraction, so that will be 0, 2. Okay, so label it, that will be 2 and negative 2 here. And then we have a 1 period, that's a 4 pi. Use the half and half method. So divided by 2, you're gonna get 2 pi. Divided by 2, you're gonna get pi. And then times 3 to get the quarter. And then times 3, you're gonna get 3 pi. Okay, so this is only 1 period, and then we want to graph the secant with 2 periods. So we're gonna make it a negative one. Okay, same thing, but become negative. Okay, so the cosine, that will be starting from 0 and 2, and then pi, 2 pi, 3 pi, 4 pi like this. And then we try to extend it. So this one is gonna be negative pi. Okay, right? Joining all the points together with the smooth curve. And this is y equal to 2 cosine 1/2 x. Okay, we're gonna graph the corresponding reciprocal function first. Okay, step 2. Sketch the vertical asymptote, and this occurs at x value for which the guide function equal to 0. Such as, okay, find it out which part x equal to 0. So this is talking about here, right? X equal to negative 3 pi, x equal to negative pi. Okay, we use the dot line to represent the vertical asymptote. And also x equal to pi, x equal to 3 pi. Okay, now we're gonna draw the U shape in between each of the vertical asymptote. So here, we do have the U here. This part, we do have the U here, U here, okay, and this is a half of them, half of it, okay. So you should have the picture looks like this. Okay, example 2. Same idea, graph y equal to 3 over 2 cosecant x minus pi over 2 with 2 period. So the corresponding graph will be the sine, right? Y equal to 3 over 2 sine x minus pi over 2. Figure out the amplitude. Amplitude will be here, the A, right? So 3 over 2. Refraction? No, because this is a positive. Period, that will be 2 pi over b. And your b, that is equal to 1. Okay, right? But we are not done yet since we do have the argument. The argument is x minus pi over 2. So we know that we're gonna shift the graph to the right pi over 2 unit. Okay, so we're gonna let this argument in between 0 to 2 pi. Solve for the x. So we're gonna add the pi over 2. You should get x is between pi over 2 to 5 pi over 2. So you're gonna shift pi over 2 to the right. Okay, now sketch the sine curve. Okay, I will have like the pi over 2 to 5 pi over 2. Okay, remember you're gonna divide it into 4 parts. So use the half and half method to figure out these two. And then you could extend it, make it like negative, the same number. Okay, now you're gonna sketch the vertical asymptote. Whatever you're hitting the 0 here, that will be your vertical asymptote. So that will be x equal to negative 3 pi over 2, x equal to negative pi over 2, and 3 pi over 2, and 5 pi over 2. So at this point, you're gonna draw the dot line has the vertical asymptote. And then you're gonna use the U shape, the upward and the downward, to represent your cosecant. Okay, example 3. Determine an equation for the graph. Okay, so this is either like the secant or cosecant. Okay, so think about it. The curve is supposed to be going up here, going down. So starting from 0, it can be like the sine curve. All right, and what is the amplitude? Amplitude is talking about here. So it should be 1, right? And also for 1 period, this is 1 period. That will be 4 pi. Okay, we do have the period 4 pi. And then calculate the period, that will be 2 pi over b, right? Which is going to be equal to 4 pi. And then solve for your b. So b is going to be 1/2. Amplitude is going to be equal to 1. Okay, right? And we say that this is going to be the reciprocal, the sine curve. So this one should be the cosecant. So we know the b already, and then we know the a is going to be equal to 1. So that's cosecant 1/2 x. So this is the equation, y equal to cosecant 1/2 x. Example 3b, determine an equation for the graph. First, we want to find out the period. So this is a 1 period graph that is from negative pi over 2 to 3 pi over 2. So we're gonna calculate the period, pi over 2 plus 3 pi over 2. So when you add it up, they do have the same denominator. It should be 4 pi over 2, which is gonna be 2 pi. Since the period is gonna be equal to 2 pi, so we know that b will be equal to 1. Now we're gonna look at the y-intercept. The y-intercept start with the 0, 2 here. So we believe this is gonna be the secant function. Okay, because remember that cosine will be starting from 1 and then going down and then going up like this. So this is the reciprocal of the cosine, which is gonna be the secant. Okay, and then the distance from the point here, you can see the whole graph is going to be shift upward 1 unit. Okay, so we could draw the line here. We move it up here 1 unit. And then look at the amplitude. Amplitude is going to be here, that's equal to 1. This is also equal to 1. So A is going to be equal to 1. So this graph, it should be y equal to c plus a secant bx. C talking about the graph shift upward 1 unit. A, that will be the amplitude. And then B, that's talking about the period here. So B equal to 1. So we plug in all the information here. So the equation of the graph is going to be y equal to 1 plus secant x. That's it.